Welcome to episode 174 of the Microsoft Cloud IT Pro podcast, recorded live on April 16, 2020. This is a show about Microsoft 365 and Azure from the perspective of IT pros and end users, where we discuss a topic or recent news and how it relates to you. In this episode, we talk about Azure services for Linux and Azure web apps for containers as a hosting option for microservices.
You've made it to another Friday.
Is that what day it is?
It is. As Rebecca Black. You remember that song, Friday?
Oh, no, please.
Yes,
please.
no.
No.
Well, hold on. As she taught us, Friday is the day that comes after Thursday, right? Yesterday was Thursday. Today it is Friday. Partying. Boom.
But that would assume that I knew that yesterday was Thursday.
Yep. Well, I'm just telling you, like, hey, Rebecca Black could help you get through COVID-19.
No.
Just to throw that out there for you.
Well, we're almost through it. We have our escape plan now, right? As of yesterday.
Yeah.
Although there's no timeline on our escape plan. It's just a plan. This is how we're going to escape at some point in time.
Well, it's phased and it's gated. It's very DevOpsy. They got that going for them. So... But, you know, our beaches are reopening today. We got that going for us.
But only for a few hours, right? Because I saw they're opening today at 5, but then it was like 5 to 8 p.m. and then 8 a.m. to 11 a.m.
Yes. Yeah.
Which
so
means,
6 hours a day.
Yeah. They're essentially trying to avoid people going out and hanging out all day. Because let's face it, in Jacksonville, nobody goes to the beach from 8 to 11 unless you're going to go for a walk or run or something like that. And same thing from 5 to 8. It's... hey, you can go take a walk, you can go take a run, you can go exercise, but you're not going to go lay out and party at the beach all day.
Yeah, no, it's one of those, I go kind of like two ways about it, because you know people are going to abuse it.
Right.
No matter what. There's going to be lawn chairs and things out there. Now people have to patrol it and all those kinds of things, but I am genuinely looking forward to just going back to the beach and being able to, like, stick my feet in the ocean again. Like, that's one of the advantages of living here, right? And being close to all of that. So yeah, I'm sad I can't take a lawn chair with me, but I'm not going to be one of those people. But I am totally going to go stick my feet in the ocean.
Oh, did they say no lawn chairs too?
Yeah, they don't want you, like you said, congregating or any kind of chance of that going on. So we'll see.
I missed that part. It was interesting though, because it was
in like the sheriff's webcast about it.
Okay.
So it's not in the official thing, but they did call it out in the sheriff's one. So I think they're going to be kind of going by and talking to people. And
so did you read the whole article? This made me laugh. Primarily because it's so interesting to me. I have family in other states, and everybody has their different definition of essential activities when they put these stay-at-home orders in place. It's like, hey, you can only go on the beach for essential activities. And in Florida, based on the governor's executive order, essential activities include participating in recreational activities consistent with social distancing guidelines, such as walking, biking, hiking, fishing, running, swimming, taking care of pets, and surfing. Mm-hmm. So if you're in Florida, surfing, swimming, I mean, I get some of it's exercise-based, but then you look at places like Michigan where they're not even allowed to do any residential or commercial construction projects. Those are considered non-essential. In Florida, surfing is essential.
As it should be. I have a weather reporting app. So I don't surf, but I go out and go paddleboarding. And the weather reporting app follows all the cameras up and down the beaches and the intercoastal here, just so sometimes it's not about even like wind speed or tide or things like that. It's really just about how calm it is out there, because there's some parts of the intercoastal and things that are
paddleboarding in like 6-foot waves.
You know, so sometimes I would, but my paddleboard's an inflatable, so just so it's a little bit more portable for me to get around, and it needs to be like really calm and really flat in the ocean just to kind of keep the stability you need. It's not a paddleboard that you would necessarily surf in on.
Got it.
You know, if I went out and bought like an 11-foot board that was a hard deck, then I could do some different things. But yeah, I'm looking forward to having the ability to have just at least one extra option for something to do.
Yeah, no, I get it. Like, I totally wish we lived closer, and who knows if this goes on much longer, we may just drive out there some morning just to let the kids go run around and walk on the beach for a little bit, because we are starting to get a little stir crazy.
Just bring your bikes, you park at my house, you make the kids ride their bikes to the beach, and then make them ride back, and they're all good and tired, you know. All set.
Except then they fall asleep in the car on the way home, and then they don't want to take a nap.
Well, it just means you get to drive the car around longer. It needs to be run anyway. It's not like you're
really
going out
does.
every day anymore.
We were talking the other day. We can't even remember the last time we put gas in the car.
It's been a while. So I had to run an errand yesterday, or at least I thought I had to run an errand, where I was just going to go pick up my dog's medication, like flea and tick stuff, right? We ran out.
Yep.
And so I was walking out of the house, and my wife said, "Oh, don't worry about it. I've got to go out later to pick up groceries, so I'll go do it." And I thought to myself, I'm already like halfway out the door. I put my keys in my pocket. I got like my wallet in my pocket. This hasn't happened in a long time. This is, exciting. So I kind of stood there in the garage with the garage door open, looking at my car. And I said, all right, well, I'm just going to start it up because it's got to be started anyway. And then that turned into, I should really just drive it around the neighborhood. So I went for a nice, like lazy roll, just kind of like basically around the long block, which, takes like 10 minutes to drive around the neighborhood and do all that. And I was like, yeah, I got to drive a car today. That was crazy.
Did you put your seat back, roll down your windows, and crank up your music too?
No, I really should have, though. Everybody likes to see that Malibu rolling through.
You got to show it off. Oh, here is your new quote, Scott. This came from Michigan's governor. Speaking of quotes from governors, it is better to be 6 feet apart right now than 6 feet under.
Yes. That true statement. Your outlook on things. Yes, that is absolutely true.
Oh, things that make us laugh. Yeah, I have all kinds of those. I will say the memes out of all this have been great. So, with all that said, should we talk about other stuff?
Yeah.
Like cloudy stuff?
Yeah.
Since is it cloudy today? It's supposed to be rainy this weekend. That's the only downside of the beach is opening. It's supposed to rain all weekend.
I will make do.
All right, take an umbrella. Outlook add-ins are a great way to improve productivity and save time in the workplace, and Sperry Software has all the add-ins you'll ever need. The Save as PDF add-in is a bestseller and is great for project backups, legal discovery, and more. This add-in saves the email and attachments as PDF files. It's easy to download, easy to install, and Sperry Software's unparalleled customer service is always ready to help. Download a free trial at sperrysoftware.com, SPERRYSOFTWARE.com, and see for yourself how great Save as PDF is. Listeners can get 20% off their order today by entering the code CLOUDIT. That's CLOUDIT, CLOUDIT, all one word at checkout. Sperry Software, work in email, not on email. So, Azure Web Apps is something you said you have been working on recently, and you said we should talk about it.
Yes, that is in fact true. So I've been doing a fun little project at work. It's a little bit of a transformational project of taking an existing series of microservices that are all hosted in Azure Kubernetes Service today and seeing if we can't break those microservices out and potentially host them in another hosting container or another provider that's going to allow us to run those web apps and do it with the same performance characteristics and monitoring kind of operational insights we need, but at a much cheaper cost. So if you think about something like AKS, you stand up a cluster and typically you want some kind of HA because it's a cluster. So you're going to want multiple things like multiple nodes in a node pool. You've got AKS, the way it works is you spin up a cluster, you get a cluster master. The cluster master is a VM, but Microsoft doesn't charge you for it. It's part of the management plane. So the master is free, but you do pay for the underlying compute. So for every node that you spin up in a node pool, then you're going to pay for each one of those nodes. So, you take two DS2 or D2S V3s, that cost whatever they cost, $70, $80 a month US.
Right.
And okay, well, actually, no, those are even more. Those are like the DS1s.
Are those like 140?
Yeah, they're like 140, right?
Are...
So you spin up two of those, and that's $280, and those VMs need to be on all the time, right? So the master talks to them, and you want that HA, and that's kind of like your baseline and where you want to be at. And that's before you start talking about other services you might consume on the side. So like in the case of these microservices, they talk to an Azure SQL database. So there's consumption there. There's storage consumption for diagnostics. There's all the things that you need to spin up with, log analytics and Azure Monitor for containers and all these other things. So there's been some releases over the last year or so in Azure Web Apps that potentially give us a way to host those microservices natively within Azure Web Apps and gain some efficiencies. Performance characteristics we want to keep the same. So, we should still keep doing load testing and make sure, we're baseline for latency and average response time, things like that. But from a cost perspective, with Azure Web Apps, your unit of compute is your app service plan. An app service plan can host multiple web apps inside it. So if I can find a good app service plan tier to host all these microservices in and keep the performance baseline the same, it should theoretically be a little bit cheaper, better, faster to operate and stand up along the way. There's some things that you're going to get with web apps. Like you're going to be potentially fixed in storage size. Your app service plan determines whether you can use custom domains and SSL and things like that along the way. But, if you can find a way to land in like a Linux web app in a standard service tier, the standard service tier starts at about $70 a month. And, you can scale up to 10 instances within those. And even if you go to like the premium tier, you get into the premium tier, at least here in the US and like East US and East US 2, it's $73 a month to start the premium tier. And things like that can scale up to 30 instances. They support auto scale, custom domains, SSL. You can do kind of all the things you need to do within there potentially to stand up those workloads and get them to where they need to be.
Got it.
So in this case, like we looked and we said, okay, what's a good like target service plan size just based on performance characteristics of existing apps? Because we were actually kind of leaving a bunch of compute on the table inside those existing AKS nodes. They were kind of sized up a little bit further than they needed to be. But even if we had downsized them, cost still would have been a thing, particularly when we factored in storage and everything else. So we just started out kind of simple and said, hey, can we run it in a standard plan? Like, could I run it in an S1? If I severely restricted the RAM, like an S1 app service plan is 1 core and 1.75 gigs of RAM. But again, it's only $70 a month. So if I can run it inside of that for the core compute, 280 versus 70, all of a sudden I've got a bunch of flexibility and I can do some other things there.
Right, because now your web apps are naturally highly available. You're not having to go make sure you have 2 VMs and configure all that for your high availability. It's all just built right into the app service.
It's supported within the app service, yeah. So there's this concept of instances that you can run. So effectively, kind of how many scale units or, what does your horizontal scale look like within the app service? So by default, you usually run with 1 instance, but you can go in and change that configuration and say, I always want to run with 2 instances or 3 instances, and then maybe have things like auto scale rules based on CPU or some other metric that you're going to target auto scale. And in the case of these service plans, right, being able to scale to 10 instances or, 30, 50, depending on your service tier.
How do the resources compare then when you're talking like VMs? Because obviously you can also go out and get a VM that has a gig of RAM and a single core and is really cheap. But then those resources are also having to go to the underlying OS. When you do this in the web apps, are you getting essentially the same amount of resources? Figure you're still getting like a core and a gig of RAM, but then it's dedicated 100% to your web application and to those microservices. It's not having to share those resources with some underlying OS.
Well, I mean, there's an underlying OS. So you're picking whether you're on Windows or Linux. You're just saying you don't want to have to worry about patching the underlying VM there. So kind of the way it works in Azure Web Apps, have you ever heard of ACUs?
Yes.
All right. So an ACU is an Azure Compute Unit, just for those that aren't familiar with it. And they're meant to be a way to baseline or compare CPU performance across these different size and series, right? So when I come out and I say, okay, a D2S V3, and you go, what the heck's a D2S V3? And how do I compare that to DS1 V2? Well, you would potentially do that through something like ACUs along the way. They start at A0. Actually, it's a little bit easier to start in like the A1 kind of family. So A1s are 1 core to 1 vCPU. So it's a 1-to-1 relationship. And the ACU, the Azure Compute Unit, is 100. So now you got like a nice solid whole number that you can work off of there. So when you go to pick your app service plan and what your unit of compute is, like if I went in and selected an S2 in the standard series, well, an S2 aligned core, so it's 2 cores and it's 3.5 gigs of RAM. Then you go like, all right, well, what does that really equate to in CPU performance? Because 2 cores in a D series versus an A series, they're actually going to have kind of some different metrics to them. So then I can walk in and I can say, okay, well, an S2 is 200 total ACU. It's an A series compute equivalent. Like I know where I've landed in there, and I can start to figure out what I'm getting for my money with the features that are offered to me. Or if I go into the premium tier where I can do maybe like isolated networking and some other things, those are going to be like DV2 series equivalents, and you start to get into all the way up to like 8x metrics. Like you can do like 840 total CPU, like 14 gigs of memory in a P3 V2. So it gives you a little bit of a baseline and kind of a way to figure it out. So if you looked at, say, like in this case, the node pool, or you knew you were running IS or Apache or whatever it is on a VM, and you know what kind of VM you're on, now you can play with it a little bit and see like, hey, would I actually be able to step down from a D series to an A series, which potentially has some significant savings for me? Am I really CPU bound, or am I memory constrained, disk constrained? What's the constraint for my application as you stand it up?
Got it. Okay, so you have all of that. You've figured out how those resources align, how you're going to go from one to the other. But now you actually have to move those microservices or those containers. What do you have to think about then as you take these microservices that maybe you're running in AKS and you want to push them into one of these app service plans? Is it just like a lift and shift, or is there some reconfiguration that has to go on there? Because I honestly completely missed this, and I had no idea you could actually run microservices and app service plans now.
So specifically containers, right? We're talking about taking containerized applications that are already containerized and being able to bring them over. So like in the case of AKS running the Docker container runtime or kind of Moby already, we should be able to natively come over to a service like Web Apps for Containers running on Linux, which already has a Docker runtime as well, and stand a container up the same way. So you could always do microservice hosting, right? Just deploy your web app as the runtimes or kind of the server side or static frameworks, whatever you had going on into Azure Web Apps. That was fine. But the nice thing here is we're just lifting a container and getting it to where it needs to be. So there's a couple of things, like in this particular case, that ended up being kind of interesting. So if you think about standing up something like an AKS cluster. So it's a container orchestrator. So it's bringing things to you like service discovery. There's certainly networking components to it. So if I'm deploying a microservice on a cluster, how does traffic from the outside hit an IP, and how does it know to hit that IP and then be routed all the way to that backend service, specifically to, microservice A versus microservice B? So that all happens with other services or load balancers that you might deploy. And typically you want some kind of ingress controller where maybe you can have more play within the routing of that traffic. You might not always want like just a standard kind of load balancer service in there. So for this one, it was an existing implementation of Traffic. So it's just a kind of a way for us to stand up websites and do the routing and things like that within that cluster. But that meant that traffic was going away when we came over to the other side. So in AKS, the way everything was set up is there was a root URL. So, there was msclouditpropodcast.com, and that was kind of the homepage. And then the APIs were all stored in virtual directories or virtual routes underneath there. So you would have like /API1, /API2, /API3. So everything was in the same canonical and fully qualified domain name. And when we went to Azure Web Apps, well, that changed a little bit because we can't run multiple containers. We can't run like a whole container group in Azure Web Apps.
Got it.
Inside the same web app. So what was, 5 or 6 containers that were all effectively the same website from a routing perspective actually became 5 or 6 separate websites on the other side. So there was some reconfiguration that needed to be done there, right? Like things like, okay, so, a dynamic configuration for which API endpoint we talk to, where there was only one URL. Now there needed to be one distinct like environment variable that we could set for each API so that you could still talk to the right place and grab the right thing. But the really cool thing there is because it's all just containers, right? So we can go change the code, we can spin it up, we can create a container image, and we can spin that up very quickly within Azure Web Apps. And it turns out that with Azure Web Apps, it's potentially even a little bit easier for us to do the deployment. So something like that dynamic configuration where it was all running inside either a native Kubernetes deployment, or in this case, everything was being deployed with Helm and Helm charts, and you're setting dynamic values for environment variables and things like that. In Azure Web Apps, you've got native just app settings, like there's configuration per web app, and all you have to do is go set those keys within the app service, within the web app configuration, and they're automatically projected as environment variables within the web apps, within the containers that are running within the web app and within that runtime. It was super slick and super kind of turnkey. Just to spin up a container and run it was a very quick thing to do. It felt nice and easy, and way easier than potentially, depending on your feelings on it, muck with a bunch of YAML to do like the existing Kubernetes and Helm deployments we're going through.
As IT professionals in the cloud era, sometimes it feels like we don't speak the same language as the rest of the organization. So when stakeholders from finance or other departments start asking about a specific project or team's Azure costs, they don't always realize how much work is involved in obtaining that information, sifting through cluttered CSVs and a complex mess of metadata in order to manually create custom views and reports. It's a real headache. On top of helping you understand and reduce your organization's overall Azure spend, ShareGate Overcast lets you group resources into meaningful cost hubs and map them to real-world business scenarios. This way, you can track costs in the way that makes most sense with your corporate structure, whether it's by product, business unit, team, or otherwise. It's a flexible, intuitive, and business-friendly way of tracking Azure infrastructure costs, and it's only available in ShareGate Overcast. Find out more on sharegate.com/ITPro. Got it. So really from that migration standpoint then, and moving from one to the other, there's not a whole lot that has to change in your containers other than kind of how those different APIs would talk to each other, how those different containers would talk to each other. Other than that, a lot of it's just more or less a lift and shift of containers into the app service?
Yeah, it's really saying, hey, can we validate this? Like from just a very much like raw proof of concept side, like do these things work? Yes or no? And then what kinds of efficiencies can we light up along the way? So for something like web apps on containers, so in this particular case, if you think about kind of container lifetime, right? You have something like a Docker file that builds the container.
Yep.
So you build that container, and then you want to push that container image to a registry, and then you want to be able to pull from that registry based on a container name and a tag and things like that. So we were using Azure Container Registry, or ACR, as our container registry. So it's a Docker compatible container registry, supports like Docker push, Docker pull, things like that along the way. So it's a nice private registry, so you don't have to go out to Docker Hub or anything like that. We looked at ACR and kind of the way existing builds were going on today. So existing builds were happening on build agents as part of like a continuous deployment, like a CI and CD pipeline. And to do those builds, you need to have the Docker daemon, not just the Docker client, but you need to have like the full Docker runtime to be able to do a Docker build. So that means that you need a Linux server stood up, or if you're doing Windows containers, you need that compatibility, but you effectively need a unit of compute to do your build for you. So if we looked at like the CI CD deployment side, that meant we always had to make sure we were picking the right build agent. Did it have the right version of Docker on it? Was it bootstrapped the right way and doing the right things to be able to execute builds based on our Docker files? And it was just like an extra piece that you needed in there. So being that everything is in ACR, we actually wanted to see if we could light up some new options there. So one of the things that happens inside ACR is it has a feature called ACR build tasks. So what you can do is you can send a Docker file, basically kind of like think about like maybe zip it up in like a tar or a gzip, and you can send it up to ACR, and ACR will do your build for you. So the unit of compute is built into ACR itself. I don't need that separate build agent to run Docker build and then do a push to the registry for me. So it kind of simplifies things, right? What was potentially two different steps and two different commands and having to worry about logging into a registry and things like that. Now in that CI/CD pipeline, it's just running an Azure CLI command and making sure that I'm authenticated to the CLI through a service principal or a user that has access to that registry, which is really kind of cool. So why is it good that I can do things like do this ACR build task or this ACR task directly inside of ACR? Well, if you think about one-off builds, like one of my struggles with Docker has always been, am I on a computer that has all the tooling installed that I need? Do I already have the Docker client? Do I already have the Docker daemon? Am I in an environment where I can actually do a Docker build? And sometimes the answer is no, right? You don't know. You might be at like a customer's environment and on like a laptop that they provided for you, and you can't even install Docker on it, right? It's not allowed. It's locked down. Well, the cool thing about ACR build tasks is it's the unit of compute and it's doing the Docker build for me just based on my Docker file. That means that I can perform Docker builds from places where I don't have access to the Docker daemon. So for me, that means that I can go into this environment. If you think about just Azure, I can fire up Cloud Shell now. And all I need to do is have access to that Docker file from Cloud Shell, so I can still do something like a git clone and clone that Docker file out of the repository it lives in. And then I can just send that file to ACR build tasks. There's no way I could build a container natively inside a Cloud Shell because Cloud Shell is already running in a container, right? It's like too many levels of virtualization removed.
It's container inception.
Yeah. So all of a sudden you've gained this really cool new ability. And it has simplified that pipeline potentially, right? What was two distinct actions, a build and a push, now it just becomes a single action, which is a build task for me. And I'm off to the races and ready to go, which is really, really kind of cool. Like it really simplified overall environment deployment. Because now, from a deployment perspective in the past, you would like to stand up, say, like a new dev environment for a developer. They had to have all that tooling locally. Now that everything's 100% Azure native, including the Docker builds, now we were able to go to those developers and we can just give them a bash script and they can go into Cloud Shell and run a bash script and come back in 10 minutes and everything's just kind of done for them.
Nifty. So you could do all of this now from a Chromebook.
Yeah. Oh, yeah. Yeah, no, I've been living in like
an iPad,
just a web browser, and yeah, it's all been going swimmingly. I've been really impressed with it. There's certainly some things that have changed along the way. I think particularly like operationally. So it wasn't so much can we do it? It's it can be done. And certainly there's that cost component to it. But can you continue to run the service in the way that you need to run it. So if you think about kind of AKS is a PaaS service, but ultimately you get a lot of insight there, right? You can dig pretty deep onto those VMs and things like Azure Monitor Containers with the dependency agents, like they're giving you some pretty raw numbers that then you can consume in tooling that maybe you're already familiar with, like Grafana or Prometheus for doing dashboards and kind of optics for operations. By going to kind of 100% Azure native services, some of that changed. So potentially things like telemetry that you get out of that web app for container. Well, because it's running in Azure Web Apps, if you haven't instrumented the container, so it's talking to something else like App Insights, which in this case, it wasn't instrumented for that. Rather than saying, okay, let's make another big code change and implement App Insights across the board, let's see what we can get out of native Azure metrics. So metrics through like Azure Monitor are just based on the existing resource providers. So in this case, Microsoft Websites. So what are the metrics that I can get out of Microsoft Websites? And now that I don't have Grafana or Prometheus for my dashboard, what can we do with maybe building out Azure dashboards or using things like workbooks to get those visualizations back to where they need to be? And so, the security team and the operations team can understand where things lay out for these applications in their updated architecture and kind of what that looks like. That might change things a little bit. You might be locked into, say, you might be look at like CPU time as a metric from a virtual machine. Well, in Azure Web Apps, you can do an aggregation across like average CPU usage. Effectively the same thing, but it might look a little bit different. You might have to figure out just what is that difference and does it fit my need and is it really there and ready to go for me?
Got it. Very cool. More stuff to play with. I don't have time to play with all this stuff.
Yeah. It was really slick as just kind of a validation exercise to say, hey, do these things work? And can we figure out where the pain points are going to be or potentially where those rough edges are going to be with that service, app service on containers along the way. So, we certainly ran into things like we had a container, which was just a .NET Core web app. It was one of the microservices, but that was just through like its initial build process. It was ready to come up on port 8080 internally. And then, you're just doing port mapping at the service level in AKS to say like, no, it's really 443 mapping to 8080 on this container and blah, blah, blah. So we had some things to get over like that. And there was another .NET Core API that was misbehaving a little bit in Azure Web Apps. So it turns out like Azure Web Apps, when it goes to start your container, one of the ways it figures out container health for a website is just by effectively doing pings into it. So by pinging your website just on port 80. So for some of these APIs, just based on routing, because they were at like /API/1/API/2, things like that. If you just went to /API/1, just like the root homepage or root route of the API, we weren't actually returning any responses. So things like Azure Web Apps would die and it would just fail the container. It would say, I can't start it because the website's not up. It's like, hold on, the website's there. You just need to look in this other place. Or we needed to, in some cases, like shut off availability checks just to get the apps up and running. And then over time, we can fix those errors and kind of get them to where they need to be and do that more transformational remediation. So from a lift and shift or just a straight up like rehost perspective, going from AKS to web apps for containers, super minimal change. Like if I hadn't had to change those environment variables, there wouldn't have been a reason to change anything along the way, right? It would have been just a straight one-to-one. And then potentially these other more transformational changes pick up and like, hey, let's make that API run the right way so that we can keep availability checks on, because that's kind of an important thing.
Right. Very cool.
Yeah. So
sounds like a fun exercise.
It was definitely different. It was something to do that was potentially a little bit different from virtual machines and tag into some new stuff and potentially solve some pain points. Like, honestly, like I walked away and I was at the end of it, I was like, this ACR build test thing, I can use this all the time in my workflow now, even for demos and webinars and things like that, where now I don't need to worry about, was my Hyper-V VM for Ubuntu up to date and ready to go? Because I always had to have a separate VM to do that. You can't do it inside of WSL1 today. Like you can't do that Docker build because again, you don't have the daemon there. So it just simplified like a bunch of things. And I just thought that was like one of the coolest features because it's going to make my life a lot easier for demonstrations and webinars and everything else, being a little selfish.
Yeah, definitely. All right. Sounds good. Well, thanks for that episode.
Yeah. No worries.
Another fun Azure one. So go enjoy your weekend now. Go get out to the beach. Get some fresh air.
Yeah, it is one of my goals.
All right. Sounds good. We'll enjoy. Good talk to you, and we'll talk to you again next week.
Thanks.
If you enjoyed the podcast, go leave us a 5-star rating in iTunes. It helps to get the word out so more IT pros can learn about Office 365 and Azure. If you have any questions you want us to address on the show or feedback about the show, feel free to reach out via our website, Twitter, or Facebook. Thanks again for listening and have a great day.